first one right here, I would have expected you to get this first one correct. The first one is a straightforward confidence interval, so you're just using the formula for the standard error. So you're using the p hat 1 and the p hat 2 and the n1 and the n2. So in this particular one right here, we could say that the p hat 1 is the 331 over the 405, which is about 0.82. The p hat 2 we'll say is the 302 over the 403, which is about 0.75. So you're just using 0.82 and 0.75. You're doing a 90%, so that's 1.645. So this one's not right. This one's not right. And this one's not correct. So then out of these two, if you look right here, this one is using the p hat c. So your p hat c is going to be that 633 divided by the 808, which ends up being about 0.78. So it's those two numbers added together in the numerator, these two numbers added together in the denominator. So you get about 0.78. This is using the p hat c. We don't need the p hat c in the confidence interval, so we would use B would be the right answer for this one. This one is the one I expect you to probably have gotten wrong. Right here, when you're doing the significance test, this one, it should be the p hat c, because you start off by saying you think those two are equal to each other. So even on the formula sheet, it says when p1 equal p2 is assumed. So then they're using that p hat c. So it's like this, but instead of with the ones, you have the c's there. So it's p hat c. So this one, these two right here are not correct because their numerator should be the p hats. So you can see right there, I mean, that's just your standard formula there. So it should be p hat 1 minus p hat 2. So all of the other ones say 0.82 minus 0.75. Again, you should be using p hat c. So this one's not correct. It doesn't use p hat c. These two are both using p hat c. What you notice is wrong with this one is that the square root, it's split. So E is the correct answer. Both of those things are multiplied, divided, added up, and then you take the square root. You don't take the square root individually. On the back, again, this one here, we don't have to worry about any p hat c's or anything like that. So it's just going to be the mean of the one minus the mean of the other one. That's the numerator for all of them. And then the denominator is it's going to be your standard error. So it's going to be your s1 squared plus divided by n1, s2 squared divided by n2. And again, the whole thing is under the square root. So if I look here, this one doesn't have a square root in the denominator. This one does not square the s's. This one does not square the s's. So then we're down to this one and this one. And you notice here, they look the same, but then you look here at z and this is t. So your answer is t. So t is equal to that. Once you're plugging in that s and not sigma, you're using t, the t distribution. The challenge here with this one is when you need to set up those degrees of freedom, you're not going to use that crazy formula, so you're going to have to find the conservative degrees of freedom. If you look up above, you have two sample sizes. You have 110 minus 1, which would be 109 is 1 degree of freedom. The other one is 100 minus 1, so it would be 99. So you always use the smaller one. So we would say degrees of freedom are 99. Then I would take my inverse t. You could use 0.995 because that would be the upper one. Remember, this is always area to the left. The degrees of freedom we just said were 99. I hit paste. I get that number right there. So 2.62. So this one's not right. That's using z. This one's not right. That's using z. So then I'm left with these ones. Again, It's kind of the same. Everything else here looks the same. This one, though, these... Oh, sorry, this is different because it's 6.22. That's wrong. That's, I'll show you what common error that one is. So this is the only one that's squared. So this is D.